Welcome everyone to today's AI on AI podcast. I'm thrilled to be your host as we unpack some groundbreaking work on using reinforcement learning to incentivize thinking in LLM-as-a-judge models.
Thanks for having us. This paper on J1 is a fantastic blend of creative reward engineering and advanced RL techniques to train models for more accurate evaluation.
Yes, indeed. What really caught my eye was how they convert judgment tasks into verifiable tasks using synthetic preference pairs. It's like turning a subjective art into a precise science.
Absolutely. From a business perspective, imagine the impact. Companies can harness such models to automate quality assessments, effectively saving time and improving decision accuracy.
I agree, and think about how a retail giant might use these evaluated judgments to fine-tune customer service bots. It's like having a virtual inspector that's continuously learning and improving.
And technically speaking, the use of GRPO for online reinforcement learning is quite brilliant. The fact that GRPO can optimize both intermediate reasoning and final verdicts without relying on a separate critic model marks a significant leap.
Right on point, Expert 5. The dual approach of pairwise and pointwise methods seems to be one of the core innovations here, with each tackling bias differently.
Exactly. Pairwise J1 uses both order training to mitigate positional bias, while pointwise J1 inherently avoids this by processing responses individually. It's a clever design trade-off.
And the technical deep dive shows that the pairwise method even improves consistency by encouraging the model to outline evaluation criteria, compare against self-generated reference responses, and reevaluate its predictions.
From the strategic business angle, this kind of consistency is gold. Imagine automated systems that not only give scores, but also explain their rationale. It's like having a digital mentor auditing quality.
I remember reading that companies are already leveraging similar methods. For instance, one financial firm used advanced reward models to streamline risk assessments, cutting decision time by nearly 15%.
Indeed, those real-world applications speak volumes. And let's not forget the experiments with test time scaling using self-consistency, which improves performance by averaging multiple generations, almost like ensemble learning but within a single framework.
That self-consistency trick is fascinating. It's like asking for multiple opinions in a boardroom meeting before making a final decision.
Precisely, it echoes Einstein's famous quote, "Imagination is more important than knowledge." Here, expanded reasoning through multiple samples results in a more robust judgment.
And technically, by sampling more chain-of-thought generations, the model reduces ties and vastly improves positional consistency. This aspect opens up avenues for fine-grained comparative evaluations.
Speaking of comparisons, it's interesting how the authors compared J1 to models like DeepSeek R1 and EvalPlanner. The fact that a model trained on just 22K synthetic pairs outperformed others using far more data is truly disruptive.
That's the beauty of efficiency. Less data with more targeted training rewards can yield superior performance. It's like the 80-20 rule in action. 20% of effort giving 80% performance.
And let's talk about the reward design. The paper shows that only assigning positive rewards for correct judgments led to the best outcomes. It's a refreshing simplification compared to more complex reward schemes.
This simplicity in design resonates with many successful business strategies. Clarity and focus often outperform overcomplication.
It also implies that the RL algorithm can concentrate on the task at hand, establishing a clear baseline for correct evaluations, much like a well-calibrated measurement tool in experimental physics.
One technical nuance that impressed me was the mitigation of judgment bias by training on both orders of response pairs. The rigorous ablation studies underscore that even with consistency rewards, the inherent differences between pairwise and pointwise remain critical.
That's a key strategic point. In any business application, ensuring fairness and consistency in automated evaluations is crucial, especially when these systems influence high-stakes decisions.
Indeed, imagine an HR tool using such an LLM as a judge to rank candidate responses. Bias could make or break the hiring process, hence, mitigating it is vital.
And it's not just about fairness. The point-wise model's reduced tie rate is a great indication of improved clarity in scoring, which is essential for scaling these systems up in real-world applications.
Expert 2, you mentioned scaling earlier. Could you elaborate on how test time scaling, like the mean score at 32 approach, augments both pairwise and pointwise judgments in these models?
Certainly. The idea is that by generating multiple chain-of-thought outputs and averaging the final verdicts or scores, the models can overcome any random fluctuations due to single-sample stochasticity. It's akin to having multiple auditors review the same financial report.
That analogy is spot on. More technical iterations at test time allow the model to capture a more stable consensus, reducing noise in its judgment.
And on the business front, this could translate into more reliable metrics for consumer feedback systems or quality assessments, ensuring that strategic decisions are taking into account a broader consensus rather than one-off outliers.
Speaking of real-world examples, a major e-commerce platform recently integrated a similar self-consistency technique into its review analysis tool, resulting in a measurable 10% increase in customer satisfaction through quicker resolution of service issues.
That's the intersection of deep technical innovation and practical business impact. By leveraging such methodologies, companies can achieve a level of evaluation that was previously only possible with much larger, less efficient systems.
It's almost like rebuilding an engine while driving a high-speed car, a challenge that requires both technical acumen and strategic agility.
I love that analogy. And to add a humorous note, Expert 4, are you sure you didn't invent this technology just to confuse us with all those sampling techniques? Well, technology and business have always danced this tango. Sometimes the steps are complicated, but they always lead to a better performance.
Now, circling back to the reinforcement learning aspect, the group relative policy optimization algorithm used here is particularly intriguing. Instead of relying on a separate critic, GRPO estimates baselines directly from group scores, which is both elegant and practical.
From a strategic standpoint, that means faster iterations and more agile model updates, which can be a competitive advantage in industries where speed and accuracy are paramount.
Plus, with RL's capacity to continuously adapt, these models will only get smarter over time. That's where the future of autonomous evaluation systems lies, learning from iterative feedback loops in real time.
Fascinating. So to sum it up, J1's approach represents a breakthrough in both the design of AI judges and their potential business applications by combining robust reasoning, smart reinforcement learning, and real-time scaling techniques.
Absolutely. It's a fine balance between technical precision and practical efficiency, which the paper captures remarkably well. And it paves the way for industry-wide adoption, potentially reshaping how companies deploy AI for evaluation and decision-making.
If I were to bet, the next big enterprise applications will likely revolve around these RL-trained judging systems, especially in areas like risk management, compliance, and customer service.
I agree. This is a step forward in making AI not just a tool for generating responses, but for understanding, critiquing, and even teaching itself how to improve.
And every improvement in the model's thinking process is like adding a new gear in a high-performance machine. The better the reasoning, the smoother the overall operations.
Well, folks, that wraps up our deep dive into the J1 paper and its many innovative aspects. Thank you all for a rich and engaging discussion. It's been an absolute pleasure.
Thanks for having us. This conversation was a delightful mix of technical depth and real-world context.
It's been exciting to bridge the gap between research and business strategy today.
I'm already thinking of how we can implement some of these ideas in our systems. Exciting times ahead.
And kudos to the researchers behind J1. It's the kind of work that sets new benchmarks in the field.
Until next time, everyone, stay curious, stay innovative, and keep thinking deeply. Thank you for tuning in. Welcome back to part 2 of our podcast. Now we're diving even deeper into the technical implementation and real-world business applications of the J1 model.
Right, let's kick things off with the GRPO algorithm. It's the backbone that enables simultaneous optimization of intermediate thinking tokens and final verdicts without needing a separate critic, which is a real game changer.
Absolutely. And what's so fascinating is how the model uses synthetic training data to simulate both verifiable tasks like math problems and subjective tasks like wild chat responses. This dual approach is reminiscent of training pilots with simulators versus real flights.
From a business perspective, that duality offers a robust foundation for enterprise applications. Think about financial firms using these systems to automatically vet risk scenarios by comparing model responses in a bias-mitigated way.
Not to mention the scalability aspect. Implementing this model on cloud infrastructures like Kubernetes clusters can enable parallel processing of multiple chains of thought, much like how auto-scaling works in high-frequency trading applications.
And regarding reward design, it's interesting how they found that a simple reward scheme, only positive rewards for correct decisions, produces better performance than convoluted penalties. It's like rewarding a salesperson for hitting targets rather than penalizing slight misses.
I like that analogy. It's clear that sometimes less is more. Expert 1, can you break down the actual reinforcement learning loop for us?
Sure, the loop involves generating several rollouts, each with about 5 different chain of thought sequences, then applying the GRPO update where the baseline is computed from group scores rather than a separate critic network, reducing variance in the update.
And this process, by averaging over multiple samples, naturally minimizes the randomness of individual responses. It's as if the model debates with itself to reach a consensus before finalizing a judgment.
For organizations, it means decision-making can be more resilient. Consider a logistics company that uses similar multi-sample evaluations to optimize delivery routes, thereby reducing cost fluctuations and error rates.
On the infrastructure side, deploying such a model would initially demand high-performance GPUs, say A100 clusters. But over time, as inference optimizations like mean score at 32 are applied, the per-request compute can be significantly reduced.
Speaking of mean score at 32, the technique of sampling multiple chains of thought and then averaging enhances the model's consistency. This is critical when business decisions rely on the model's scoring, as it avoids erratic responses that could skew performance metrics.
And let's not forget the meticulous ablation studies in the paper that highlight the reduction of positional biases, ensuring that the order of responses doesn't affect outcomes, a critical point to guarantee fairness in evaluations.
Right. The idea of creating both order training batches to mitigate positional bias is ingenious. It essentially forces the model to focus on content quality rather than presentation order.
This mitigation strategy has clear implications in sectors like HR, where candidate evaluations every single time need to be free from ordering effects. Imagine an automated interview system that remains unbiased regardless of how candidate responses are sequenced.
Exactly. And in marketing, such an approach could underpin more accurate sentiment analysis tools, where customer reviews are evaluated fairly, irrespective of their order, leading to better targeted campaigns.
Another technical nuance is in the reward consistency. The model leverages both verdict consistency and format rewards. Although the results showed that the simplest reward, like the positive correctness reward, was most effective.
I find that particularly refreshing. Sometimes complex reward functions create overfitting, but here, the straightforward positive reinforcement got the best ablation results. Sort of like how a minimalist design can be more effective than a cluttered one.
It's a great example of how simplicity in design translates into robustness in performance, both in algorithms and in business strategies.
Also, let's touch on the generation length. Pairwise models typically generate about 500 tokens of chain of thought, while pointwise models are shorter, around 300 to 400 tokens. This difference is not trivial. It affects both compute and interpretability.
True, the longer reasoning in pairwise models can provide richer context for debugging and understanding model decisions, which is valuable for risk management in financial institutions where transparency is key.
And for large-scale applications, this insight can drive customized deployments. For instance, a customer support system might prefer the pointwise variant for speed, whereas quality control systems might invest in pairwise for deeper analysis.
Not to mention that the overall inference approach, using greedy decoding for fast outputs and sampling for test time scaling, is adaptable. Enterprises can choose a balance between speed and accuracy based on their operational needs.
One contrarian thought. While many are chasing higher model scales, it's intriguing that J1 Llama 8B, when properly tuned, competes well against larger systems. This challenges the common notion that bigger is always better in AI.
That twist is refreshing. It's like finding out the compact car has better fuel efficiency than the luxury sedan without sacrificing performance.
Precisely, and this balance of efficiency and performance is essential for businesses managing tight resources while striving for innovation.
In wrapping up our technical deep dive, it's clear that the meticulous balance in reward design, training strategies, and test time scaling offers both deep technical insights and practical deployment advantages.
And from a business lens, the sheer adaptability of these methods, from customer service evaluation to risk management and beyond, opens up new avenues for leveraging AI in everyday strategic decisions.
Plus, the potential cost savings in compute and data requirements make these models appealing even for mid-sized companies looking to implement cutting-edge AI without breaking the bank.
Ultimately, J1's approach is a melting pot of innovation, where advanced reinforcement learning meets real-world practicality, setting the stage for the next wave of AI-driven evaluation systems.
Thank you all for this enlightening discussion. Your blend of technical deep dive and business insights truly highlighted the multifaceted nature of J1.
Thanks for the engaging conversation. These insights are a testament to how far we've come and where we're headed with AI.
It's been a pleasure bridging theory with practice. Looking forward to seeing these ideas implemented in diverse industries.
Absolutely, and it's exciting to think about the transformative impact this could have on decision-making processes across sectors.
Can't wait to see businesses harness these innovations to drive efficiency and fairness.
Here's to a future where AI not only thinks, but judges with clarity and precision. Cheers to that.
That wraps up part 2. Thanks again to our panel of experts and to our listeners for joining us on this deep dive into technical brilliance and strategic potential. Stay curious and keep innovating. And now, as we wrap up today's deep dive, let's summarize the key innovations we've seen with the J1 model and its reinforcement learning approach.
Absolutely, in essence, J1's GRPO-based training, leveraging synthetic data across both verifiable and subjective tasks, sets a new benchmark in how we incentivize and optimize thinking in judgment models.
Right. And from a technical standpoint, the model's dual chain of thought reasoning, with robust mechanisms to mitigate position bias, has not only refined its decision-making, but also opened new avenues for scalable, consistent evaluation in diverse applications.
And if we look at the business impact, imagine a scenario where a retail firm cuts costs by 15% by automating biased-free evaluations, or a logistics company harnessing multi-sample consensus to optimize routes. This really underlines the practical value.
Exactly, the simplicity in reward design, particularly the use of a positive correctness reward, reminds me of the 80-20 rule in business. Sometimes, a minimalistic approach brings maximum returns, all while ensuring model transparency.
Plus, let's not forget that unexpected insight. The fact that a well-tuned J1 Llama 8B can compete with much larger systems really challenges the bigger is better mindset in AI innovation.
So, to sum it up, we've explored a model that brilliantly marries sophisticated reinforcement learning techniques with real-world business feasibility, blending deep technical insights with strategic benefits.
It's a testament to how far the intersection of AI research and business applications has come, proving that enhanced judgment and fair evaluations are within reach.
And as we move forward, it's exciting to think about how these principles can revolutionize not just AI development, but also decision-making frameworks across industries.
With potential applications spanning from risk management to customer service and beyond, the future of unbiased, automated evaluations is indeed bright.
This conversation reminds us that sometimes the simplest solutions, like emphasizing positive rewards and eliminating positional bias, can lead to profound breakthroughs in efficiency and reliability.
Absolutely. And as we keep innovating, the J1 approach is poised to influence not only the AI landscape, but also how businesses strategize and execute their critical functions.
Thank you all for joining this enlightening discussion today. Your insights have truly bridged the gap between technical rigor and strategic vision, leaving us with a comprehensive understanding of J1's game-changing potential.
It's been a pleasure dissecting these innovations with all of you.
Here's to new horizons in AI evaluation. Cheers to progress and collaboration.
Until next time, keep challenging preconceptions and driving innovation forward.
And remember, simplicity can be the ultimate form of sophistication.
Thanks, everyone. Let's continue pushing the boundaries of what's possible in this rapidly evolving field.
That's a wrap for today's episode. Stay curious, keep innovating, and we'll see you on our next deep dive into the future of AI.